Hey everybody, thank you so much for attending my talk today, Full Stack Swift from Server to Watch. We have the Slack channel there on the slides, session chat Dion, so if you have any questions, be sure to post them there or to the Zoom, and I will take those at the end of my talk. A little bit about myself. Again, my name is Leo Dion. I'm on Twitter at LeoGDion. You can find me there. And I've been specializing in Swift development since day one, and I've been doing development in the Apple space for almost 10 years now. So that could be iOS, Mac OS, or our main topic for today, which is watchOS and Vapor. I've been running my own company, doing consulting and contract development, Bright Digit, since 2012 in Michigan. You can find my company at brightdigit.com. And I've been doing my own podcast for almost 2 years, and we're almost at 70 episodes. You can find that podcast www.empowerapps.show if you want to listen more to my beautiful voice talk about Swift. Today we're going to be actually talking about my app Heartwitch, which is quite the experiment. Let me explain first of all how exactly Heartwitch works. So you're gonna typically have, it's for live streamers who want to share their heart rate, and what they're going to do is they're going to go on the website, get a 5-character code after they log in, and they're going to do some way to input that 5-character code on the watch. Once they've successfully entered that code, they can go ahead and start their workout. And then that will begin the signal to HealthKit to go ahead and start listening to the heart rate. And then the web browser will share that heart rate with on the web browser window. The idea would be is you use your streaming platform to go ahead and share that browser window. So for instance, here's OBS. We're going to create a window for our Safari window here. We go ahead and select that Safari window, click OK, and now OBS has that shared. You can go ahead and restyle it, and actually you can use a chroma key green color there to give it that background, and then set up for basically full screen. And then what you can do is go in and you can do a couple of things. You can both crop and use a chroma key color to get rid of that background. So let's go ahead and we'll do the chroma key first. So now that green is transparent. And then the next thing we could do is we can go ahead and crop the top of the browser window. I think it's, yeah, let's go ahead and do that. Great. And then we're going to set it for just cropping a little bit on the left, a little bit on the right, but mostly get that top title bar window out of there. Good. Okay. So we go ahead, we have that set up, and then we can do whatever we want in OBS here. We can shrink that down so it looks like it's part of the scoreboard at the top. And now we can go ahead and stream this. So basically to somebody who's following this person on Twitch, it would end up looking basically like this. Their game would be in the background or whatever they're doing, and then they'd have the overlay from Heartwitch showing their beats per minute. Just in the last week with a certain holiday coming up tomorrow, it's been actually quite popular, which is fantastic for me. But it means I have to make sure I stay on top of things in order that horror streamers can use this app. So let's get into like how this app actually works. So we have a few components here. We have our Apple Watch, we have our server set up on Heroku, we have a web browser window, we have our streaming platform, and of course our user. So the user would go in, they would go ahead and log into their browser and then launch the Watch app. From there, they would end up getting basically that code, that 5-character code, and the web browser would make an API call to the server and it would return that code. And then they would get that code displayed in the web browser for them to enter on the Watch app. So now the user goes ahead and they enter in that code on the Watch app, making sure that it matches whatever is in the browser window. And then if it calls back to the server and makes sure that code is actually verified and correct. Once it knows that the code is verified, it goes ahead and starts the workout. And of course, that's where we bring in HealthKit, and HealthKit starts the workout on the Apple Watch. And then It'll wait for the first heart rate from the sensor, and it will send that off to the server with the code so it knows which WebSocket to look for. In this case, it'll send it with, let's say, a heart rate of 76 beats per minute. And then the server looks for the WebSocket that the browser had opened when it first started the workout on the browser. And it will go ahead and send that to the WebSocket that's hooked up to the web browser. From there, the web browser will display 76 beats per minute, and then that's where pretty much the streaming software takes it away and goes ahead and displays that and sends that out to your streaming platform, whatever that may be, displaying the 76 beats per minute. Now, the web browser component is completely built in JavaScript, actually Vue.js, but the focus of our talk today is the Swift components, which are both on the server and on the watch. And I think it's an interesting look at how maybe the future of Swift development could be by building both the backend and the front end on the server, and in particularly much more rare circumstances, which is with the watch itself and Vapor. So let's take a look at how a project like this would be set up in Xcode. So the way I have it working is at the very top, you have your Xcode project, and then you have your independent watch container. Since Heartwitch is an independent watch, it doesn't contain any sort of iPhone app component. We have the watch app and then the watch app extension. And then that's where that code essentially talks to a series of Swift packages, specifically the Heartwitch kit. And that's the main library that contains the bulk of the code used by both the server and the Apple Watch. We have the executable for the server, which is HW server. That's what's actually going to be run on our Heroku instance. We have a Heartwitch server library, which contains the bulk of the code for the actual server. And then HW monitor, which I'll get into at the end, is more just used for testing and making sure that the application works. So let's first start off by talking about the front end. Let's start off with the watch. How is this watch app actually structured within our application? If we look here, we're specifically talking about the three components: the independent watch app container, the watch app, and the watch app extension. And there's certain things we have to do in order to get this to work that's different from how most watch apps are done, since we don't have a iPhone app component here. So let's take a look at how a typical iPhone app with an Apple Watch app attached to it looks. You have your iPhone app, which then contains a WatchKit app, and then the WatchKit app contains the WatchKit extension. And essentially what they've done with independent watch apps is they've replaced the iPhone app component with, in fact, an watch app container. So more or less, when you are delivering this on App Store Connect or uploading this, it almost acts like an iPhone app, even though it's actually a watch app container. There's still some bugginess with the way certain protected resource strings are needed to set up, specifically when I had to set up the healthcat permission dialog. But for the most part, it pretty much acts, when it comes to the App Store and App Store delivery, it acts like an iPhone app. Now, let's hop back and talk about what APIs are actually used in the Watch app. So first and foremost, we have HealthKit. And HealthKit is what's going to provide us access to the health sensors on the Apple Watch. What we need to do is we need to make sure that we ask for permission from the user to get access to workouts and the heart rate. And they will also have to listen to the heart rate via the workout and its various delegates. But most importantly, we need to make sure that we update the user interface as well. And that's, of course, where everybody's best friend, Swift UI, comes in. Swift UI is, I think Daniel kind of touched on this. I would say just as much as you might lose out on the Mac with going from AppKit to Swift UI, and you might lose a little bit going from UIKit to Swift UI, I feel like on the watch, you definitely gain by going to Swift UI. There isn't a lot of components I feel like I've lost out on, or any sort of functionality I lose by going over to Swift UI on the watch. And you could sort of tell that it was the watch team, which is where Swift UI started off. And it's a big gain for me to be able to build a watch app in Swift UI. So let's take a look at how the Swift UI component is structured. So at the very top, we have a Heartwitch view, very simple, which contains two components: a workout setup view and an activity view. And the way the workout setup view is set up, and excuse me, the Heartwitch view has access to a bound to a Heartwitch object, which is an environment object. In other words, it's shared throughout our application and passed down to the children of the Heartwitch view. So like I said, we have the first screen, which is the workout setup view. And while Heartwitch view is, Heartwitch object is hooked up to the server as well as to HealthKit, workout setup view is where you're going to enter in your code and select out what kind of workout type you want it saved as. So in workout setup view, the user goes ahead and enters in the code, and Heartwitch object then is able to mediate that and send that off to the server to verify that that's correct. Assuming it is correct, it can go ahead and allow the user to go ahead and tap the start workout button. Once they've tapped that button, that's where Heartwitch object then makes a call to HealthKit to go ahead and start that workout. At this point, all we have to do is wait for HealthKit to let us know when that workout has actually started and all the piping is set up essentially. And we then are notified that the workout has started, and we switch over to the activity view at this point. With the activity view then, we're just simply waiting for our first heart rate. At this point, HealthKit then sends its first heart rate, 60 beats per minute. A Heartwitch object then broadcasts that out, both by updating the published property so that SwiftUI updates that view correctly. But then at the same time, we can also use that to send that information to our server so it can send it to the correct WebSocket. Now, at the heart of this is Heartwitch object, which kind of acts like a traffic cop for all the data that's coming in and going out. And really, this is where the power of Combine comes in, which I feel like is really the most powerful thing that has come out in the last few years from Apple, even more so, I'd say, than SwiftUI. Because with Combine, we can then direct certain data points as they come in and direct them to where they need to go. In this case, we're specifically talking about how Heartwitch object is going to manage the traffic from the HealthKit, the server, and SwiftUI. So the way these components work is we have a HealthKit, which is going to be listening into the data from the HealthKit live workout builder delegate. And as it receives data, we need to update the workout data in our Heartwitch object. At the same time, we also need to let the server know that a new heart rate has come in so it can update the display on the web browser. In order to do this, what I've set up is a series of essentially what I like to call publicist or publisher factories, so that we can create, what it essentially does is it creates the plumbing that's necessary to make sure that as certain properties are changed, we make certain calls or make certain changes necessary to the SwiftUI or for the server. So let's break this specific call here that builds out a publisher for us. In this case, it's taking in the full identifier as well as the workout data. We have our first call here, compact map, which takes in that full identifier. And the reason we need that is because if we don't have the full identifier, that is a successful match between our 5-character code on the server and the 5-character code on the watch. We don't want to move move forward with this publisher. So compact map acts as a way to both get rid of all the nulls and change our type to just a regular string. Next, we have combine latest. So combine latest is to create a tuple that contains both that full identifier that's going to be used to find the WebSocket, but also the workout data, which is essentially the heart rate. Next, we have flat map. And now flat map to me is one of the more powerful features out of Combine, because this is where we're going to make our asynchronous call to the server. And we're going to want to make sure that whatever result we get back from the server, we can then use in our application. So the way flat map is then going to work is it actually needs to be able to create a publisher. It takes the publisher and it flattens it. So instead of getting a publisher that returns a publisher, it just returns that data, which is really what we need. And luckily for us, Combine has given us some built-in publishers that we can use for that data. So in this case, we're actually going to be using a future because this is an asynchronous call. But in other cases, we may want to just return a publisher that is just a static value. In that case, we might want to look at just. Or if we want to convert an array, we might want to use a sequence instead. So here's our call. We have the future, which is an initializer that has a callback called completion here. And then we call source.workoutrepository.update. And we pass in the data and the identifier, and that's enough information that will then go to the server. But let's get even more of a deep dive into this specifically by taking a look at the actual URL session calls here. So look at what update does behind the scenes. Now, this is still all on the watch. Update takes in that workout data, that identifier, and then it takes in a closure of some sort for when that call is completed. We create the URL request based on the workout data and the identifier, and then we go ahead and make a data task, in this case, with that request. When the data task is completed, if we get an error, we know it's a failure. Otherwise, we just basically parse the response. We don't actually need the data. We just need the HTTP status code here. We can then just parse that response into either a success, true or false, or a failure. And then we just call our completion with a result. Now, notice here that our result that we're using in our completion has to match the future generic types. So for instance, result here is a Boolean of success of Boolean and a failure of error. And our future also has to be a success of Boolean and a failure of error. So that's an important part of using futures if you are going to use. So this covers specifically the part where the watch talks to the server. This is the part that sends the put request with the code and the heart rate. So the next question then becomes is, we have right here the heart rate, which is the workout data. And then we have the identifier here, which is the 26 character code based on that five character snippet. Now, let's talk about what the server is actually going to do with this. Let's go onto the server, stay within the language Swift, and see how that put call is then reacted to on the server. First of all, what exactly is a server app? In this case, it's an executable, and it's built on top of probably one of the more popular Swift web frameworks out there, and that would be Vapor. Let's again take a look at our Xcode project to see what components we're talking about here. Here's how our Xcode project looks, and the server components are going to be here under Heartwitch server, which is the library, and HW server, which is the executable that we're going to send to the Heroku instance. So here is how basically a API request can be set up, or excuse me, an API call can be set up in Vapor. In this case, we are going to have some sort of application where we can configure the code. And then we're going to set up a grouped path of API 1. And then we make sure that we accept only user authentication. So we're going to group it based on this authenticator for the user. And then we're going to set up a post call to login to create the login REST API for this. Under our user controller, we have our login call set up with takes in a request, and it returns what's called an event loop future, which is essentially a promise with the user token. And everything is done pretty much through event loop future, which has been built up by the Swift Neo team. Now, we go ahead and grab the user since we know the person is authenticated. In case they're not, we know that this will throw an error and it will basically throw a 401. We generate that token, and then we save the token to our database so that way the user is fully authenticated. Now, let's take a look at that user model and see how that looks. The app is all backed by Postgres in this case, and all we have to do is set up a user model, and we set up the name of our table, in this case user. We have a primary key with the UUID type, and then we have the email address under email and the password hash. And that's all handled for us because all we have to do is set up a user token with the model itself. And there we set up the model token authenticatable, give it the key path to the user token value and the user token user. And now we have authentication pretty much set up. So taking a look at how these dependencies work out, we have here the Heartwitch server, which is a library, and that is going to be using a lot of the code out of Heartwitch Kit, which contains a lot of the shared code between both the watch and the server. And then it's also going to be using Vapor as well. Vapor also is going to be using Fluent ORM, so that way you can talk to the database. That is the main ORM that's used by Vapor for plugging into MySQL, Postgres, or Microsoft SQL or Oracle. And then, of course, we have our Postgres server that's hosted by the folks at Heroku. How does an application like this end up getting deployed on the server, you might be asking? Well, luckily, with Heroku, everything is pretty much done through build packs. And in fact, the Vapor community has a build pack for Heroku itself. Once you have that build pack set up, it will go ahead and build the Swift code into an executable that can be run on the machine. And that build pack will automatically set up all the components needed so that the application can be run. Now, let's say, for instance, you don't want to host on Heroku. Let's say you want to host on Ubuntu or like AWS or something like that. Luckily, that's pretty easy to set up as well. Not as easy, but still not too bad. If you're setting up Ubuntu and it's 16.04 or newer, all you need to set up is Nginx and Supervisor D to make sure that you have a proxy set up for your hosting, as well as making sure that your application is running all the time and you're good to go. Luckily, we don't need to set up all that stuff with Heroku. We can just pretty much set up the build pack and be good to go. So we've covered the components here as far as deployment and infrastructure. Let's talk about how we're going to set up our Swift package. So as I said, we have the Watch app container, Watch app extension. As far as the components that are hooked up to that are set up as Swift packages, we're talking here about the HW server executable, as well as Heartwitch server library and Heartwitch kit. So here's what our package.swift is going to look like. As you can see here, we have the HW executable set up as an executable and its target, which depends on Heartwitch server. We have Heartwitch server, which has its dependency to Vapor. And we have Heartwitch kit, which has no dependencies. And is, like I said, the bulk of the code here. And then we have our dependency to Vapor, which all we have to do is set up the URL to the Git repo. And then we also have to set up the version number that we want to pull from. Let's go back to our update on the Apple Watch and talk about where that heart rate is going to go once we've gone to the server. So here we've set up our URL request, and we've went ahead and made that call to our server on Heroku. What is now the Heroku going to do once it picks up that heart rate? So here's where we've set up our put request or our put REST API call for our workouts. As you can see here, we have a put call set up API.put, where it takes in workout/ID. With that colon, Vapor knows that it's a parameter that's being passed in. In this case, it's our 26-character code that maps out to our UUID that maps out to the WebSocket. And then we're going to go ahead and from there, we take that ID that has been passed by that code, and we pull that out as the workout ID. It goes ahead and looks for the workout in the database just to make sure that it's an active workout. Once it's found one, it can go ahead and it will, assuming it has been found, it will go ahead and try to find the WebSocket attached to it based on that workout ID. If it finds it, it then sends that heart rate to the WebSocket in the form of a text. It's basically JSON with the heart rate attached to it. And as you can see here, we've decoded the workout data from the body of our HTTP request here. And we've re-encoded it back into JSON so that it could be used by the WebSocket. The database only has basically, it doesn't store any health information because there's no way I'm ever going to have to want to deal with that. It actually just has a simple row that has the ID and when it was created, when it was updated, so that I can keep track of workouts that are no longer active. So that's why I call this update at the end, is to just update the updated at or the timestamp for when the workout was last updated. So let's talk about this component here. Let's talk about how it gets the WebSocket and sends that data with this WebSocket repository. This is basically what the WebSocket repository looks like. It's pretty simple. It's just a dictionary with a UUID and a WebSocket. WebSocket is given to us by the folks at SwiftUI and Vapor. As long as you import that, you have access to that class. We go ahead and just look for that WebSocket if it's been deleted or if it's missing, and then we return the WebSocket once it's found. And then here's where we take that WebSocket, assuming we found it, and we go ahead and send the JSON off to it. I want to specifically talk about these components here, the workout data. This workout data here is actually shared throughout both the watch app and the server. And I think this is really where the most powerful piece about full stack Swift really comes in, because you can now create a structure of some type and share it both on the server and on the client itself, whether that's an iOS application or a watchOS or a macOS application. So here's the code that's in Heartwitch Kit that is used by both the server and on the watch app. And all it does is it contains a heart rate, and then all I have to do is make sure that it implements Codeable and I'm good to go. On the server, there's a little bit of tweaking. I also need to add essentially another protocol implementation content, but there's actually no implementation I need to do. I just need to make sure that I have content implemented with this code snippet here. And then now I can use workout data both on the watch and the server without needing to duplicate my code in any way or support multiple different languages. And I think, to me, that's probably one of the more powerful pieces when it comes to building an application that is in full stack Swift, that is both Vapor as well as iOS, or Vapor and Mac, or Vapor and watch. There's actually 4, I think, main components that give it a great benefit. For one, you can really take advantage of Swift packages. I've done a lot with Swift packages over the last year, and I'll be speaking about Swift packages at NS Spain in a month. And to me, like, Swift packages offer a lot of versatility, not just with the easier way to manage dependencies, but also the versatility in coding and developing applications across multiple platforms. The one trick is making sure, for instance, that a lot of the code that is only available either on the server or on the watch, I need to make sure that I take advantage of preprocessor directives. In this case, we have a class that's actually in a Heartwitch kit. And in fact, there is no health kit on the server, just in case you didn't know that. So I need to make sure that I use can import to exclude pieces of code that are not going to be used on the server itself. And for instance, if I ever want to support iOS and I don't have access to the live workout classes that are available on the watch, I can also use the OS preprocessor directive if I want to specify watchOS, iOS, Linux. I believe they're adding support for Windows soon as well for this preprocessor directive in order to have my code working. Now, I didn't have to do anything with URL session on the server itself, but it is good to know that if you are going to do anything with URL or URL session or anything like that, and it's going to be used on Linux, you need to make sure that you also import the foundation networking namespace module as well, because that is separated out on Linux. And so if you do anything that's going to support Linux as well, and you're going to be using URL session or URL or any of that stuff, you need to make sure you have this in there as well. We already talked a bit about the power of Codeable and being able to share content types both on the server and the watch as well. And Codeable is really nice. We just already covered workout data and how workout data works. Pretty easy to understand. And then all we had to do to make sure that we can use this in HTTP body of some sort is we just needed to make sure for Vapor that we implement the content protocol as well. The other thing that is really nice about going with full stack Swift and doing Swift packages is testability. For those of you who don't know, it's pretty much impossible to do unit tests on the Apple Watch or anything complex with testing on the Apple Watch. But what I've done is essentially separated out, taken out and extracted all the pieces that are particular to the watch and moved that over into just basically a library. So that way I can do unit testing on the library, which is 90% of the code that the Apple Watch app uses. And then that way I can unit test that library and I can know certainly that the application works correctly. The other way I can also test the application, and that I've done this before with as you might have seen with that HW monitor executable, is being able to easily create command line tools. I can create a command line tool that pretty much acts like Heartwitch, and that way I can test the server components, or for instance, the Vue.js components, by basically pretending to be the watch app and reusing a lot of the code that the watch app uses. So for me, like, that's really the strength of doing any full stack Swift development, both on the server and the client. Being able to refactor out stuff into Swift packages, reusing codable types and structs in your server as well as your client application, increasing the testability of your code. There's a really great test suite out of the Vapor team as well that you should take a look at, as well as being able to reduce a lot of the application into something much more easier for developers to work with, like a command line tool that essentially replicates the functionality of an iPhone app. So today we've talked about a lot. We've talked about how to set up an Xcode project for a full stack Swift application. We talked about how to build an independent watch app. We talked about how to use futures with Combine when it comes to making asynchronous HTTP calls, how to host and build and deploy a Vapor application. We talked about the basics of Fluent ORM in Vapor and setting up Postgres with that. And then we also touched on WebSockets. Mostly, I'm really glad I was able to also touch upon the power of Swift packages. If you want to learn more, there's a lot of great topics out there that I think if you want to really deep dive into. There's complex authentication methods that I've used in this application, so you're not just restricted to basic authentication. I've done stuff with job queues in Vapor that run on essentially like a cron, more or less. You could do a lot of stuff with Fluent when it comes to really advanced queries of models. There's a lot of stuff you can do with Combine when it comes to publishing and subscribing. A lot of folks ask me about HTML generation with Leaf, which is the default HTML generator by the Vapor team. And then if you want to make sure that your package is available to a lot of folks, definitely you want to take a look at what you can do with continuous integration. And then, of course, they're setting up continuous integration with the Apple Watch itself, as well as how I was able to set up testing when it comes to a watch app that is health kit based. If you're interested in any resources, I have a series of blog posts on setting up HealthKit and how that works. And then there's a series of blog posts I've done on Vapor as well. And I've talked with Tibor Bodix on my podcast as well about Vapor 4. And I also have talked with Tim Condom, who just joined the Vapor team. And the server-side Swift team. And he's got some great thoughts there. If you're interested in learning about GraphQL, but also WebSockets, definitely check out my episode with Kristaps Grinsbergs, as well as the episode I did with Donnie Walls, where we talked about Combine, and his book, Practical Combine, is pretty awesome as well. And then if you're really interested in deep diving more into Combine, I have a series of posts on Combine and using a delegate-based class like core location in order to do that at that URL as well. That's about it for me. Thank you so much. I really appreciate it. And thank you, iOS DevCampDC, for inviting me this year.